Welcome to the deep dive. Today we're going into the specs of a really serious piece of perimeter security hardware.
We are the NTI E-PBD-DO390 dual photobeam detector.
It's basically a top-tier tool in the fight against false alarms.
That's a good way to put it.
And our mission today is to unpack one huge challenge this thing solves.
Which is?
How do you secure an outdoor perimeter of nearly 400 feet and maybe an indoor one up to 790 feet and just ignore everything that isn't a real threat?
All the squirrels, the rain, the falling leaves.
Exactly. That mix of huge range and almost surgical precision. That's the whole game here, isn't it?
It is, and that gets right to its core design choice, the twin infrared beams.
Okay, so twin beams.
Right. It's not just one single beam that, waits to be broken. It needs both beams to be interrupted at the exact same time.
Ah, I see. So that immediately filters out the usual suspect.
The usual suspects, exactly. A small bird flying through, some windblown trash. That stuff won't trigger it.
But wait, if the goal is zero false alarms over that kind of distance, why not use something like radar or thermal sensors?
Good question. The advantage with this dual beam lensed optics approach is really about focused power and, more importantly, reliability in bad weather.
Lensed optics.
Yeah, they're essentially reinforced lenses. They strengthen the beam, which gives it this fantastic immunity to, say, heavy rain or thick mist.
Things that could scatter a normal IR signal.
Totally. And it also needs to survive the elements long term. We're talking about an operating range from, a frigid -13 all the way up to 131 degrees Fahrenheit.
Wow.
And it even has an anti-frost system. So this isn't just about surviving the cold. It's about keeping critical defenses online no matter what.
Okay, speaking of headaches, let's talk setup.
Well,
Aligning a single beam over that kind of distance sounds next to impossible.
it used to be. But the NTI unit has a built-in laser alignment system.
A laser.
A laser, yeah. The sources even specify the wavelength 650 nanometers.
Why is that specific number important? Does that mean it replaces the old way of doing it with like bulky meters and things?
It completely simplifies it. 650 nanometers is just your standard visible red laser. It gives the installer a very clear line to work with.
So it cuts the process down from hours to minutes.
Pretty much. And beyond just the alignment, you also get 4 selectable beam frequencies.
Okay, why would you need 4 different frequencies?
That's to stop something called crosstalk.
Crosstalk?
Yeah, it's when you have 2 detection systems close to each other, and one mistakes the other's signal for an intruder.
Oh, right. So they don't interfere with each other.
Exactly. If you're running parallel zones, you just set them to different frequencies to prevent that signal collision. And then there's a little LED indicator right on the unit for power and signal strength, which makes maintenance so much easier.
So if we zoom out a bit, how does this one sensor fit into the bigger security picture? It still has to talk to a central system.
Precisely. And it's designed to plug right into enterprise monitoring systems. The sources specifically mention digital input or RJ45 sensor ports on an EnviroUX system.
So EnviroMUX is like the central brain.
You can think of it that way, yeah. It manages hundreds of different sensors, so you just run either a simple 22-gauge 2-wire cable or a standard SATI5 network cable to it.
And all of that is packed into a pretty small box.
Very small, roughly 3 by 7 by 3 inches.
So this model, the E-PBD-DO390, it's a top-of-the-line one in our sources.
Yeah.
And the price is listed at $313.
With a 2-year warranty, yep.
That seems surprisingly efficient for this level of capability.
And that efficiency isn't just in the price, it's in how it operates. The maximum current draw is only 88 milliamps.
That's tiny.
It's incredibly low. And that's crucial for any remote sites that might be running on solar or battery backup. Every little bit of power you save extends how long your security stays up during an outage.
So in security, performance really is just another word for reliability.
At the end of the day, yes. It's about power efficiency and tolerating the environment.
So the final takeaway here seems to be that real, effective perimeter security isn't just about raw power, like that huge 790-foot range.
No, it's not.
It's about that raw power balanced with smart engineering that's designed to defeat all the common noise and false alarms.
Which brings up a really important question for anyone designing a system like this. Given that you have those 4 selectable beam frequencies to prevent crosstalk,
Right.
how much thought do you have to put into planning that frequency map when you're deploying multiple detectors? You can't just rely on physical distance. You actually have to manage the entire signal landscape to guarantee the whole system works perfectly.